Hi friends, today let us see a problem on how to implement a direct form 1 structures. So in direct form 1 structure, let us say the problem today, let us take a problem for today as this. H of z is given as h of z equals to 3 plus 4z upon z minus 0.5 minus 2 upon z minus 0.25. So now we actually have a problem given in this form. Now I only want h of z. I don't want anything to be in between. There should be a pluses or minuses. I want product, because direct form 1 structure demands that my h of z to be written as h1 of z into h2 of z, but it does not allow me to use pluses and minuses in between. So how to proceed for this problem? So when the problem is given in this form, the solution adds up one more steps. The step 1 over here is to first arrange h of z. Now how do we arrange h of z? So what I do is, because I want the product form, what I'll do, I'll keep 3 over here, and then I will do the cross multiplication of this terms. So when I do cross multiplication of this terms, I will get 4z into z minus 0.25 minus 2 into z minus 0.5 divided by z minus 0.5 into z minus 0.25. So that term will give me 3 plus 4z square, okay, 4z square minus 1z, because 0.25 into its and then z, 1z, okay, then here it becomes minus 2z, and this becomes plus 2.5 is 1, divided by the denominator comes as z square minus 0.75z plus 0.125. Okay, so let us go ahead and solve the numerator. We see over here it becomes minus 3z and plus 1. So it becomes h of z equals to 3 plus 4z square minus 3z plus 1 divided by z square minus 0.75z plus 0.125. Okay, still there is an addition sign in between. What I'll do is I'll further cross multiply, and when I now cross multiply, I multiply 3 by a big term, that is z square minus 0.75z plus 0.125 plus 4z square minus 3z plus 1, the whole now divided by z square minus 0.75z plus 0.125. Okay, now if I multiply inside, that becomes 3z square minus, okay, 3 5s are 15, 3 7s are 21, 122, 2 carry 0, 2.25 z plus now 15, 1 carry, 4 to the 3 to the 6, 1 7, 3 1s are 3, 0.375 plus 4z square minus 3z plus 1 divided by z square minus 0.75z plus 0.125. Now we see here this 2z square can be added together and will give me 7z square minus 2.25 into minus 3 will get added up together and gives me 5.25z. Okay, then okay, so that is 5.25z, it's correct, and then I get plus 1.375. That is the numerator part, and the denominator I write here, which is z square minus 0.75z plus 0.125. Now still it is not in the proper order, because now I am getting 7z square minus 5.25z plus 1.375 divided by z square minus 0.75z plus 0.125. Okay, what I do is I divide numerator and denominator by z square, because I want the term to be in power of negative indexes or negative power of z. To bring them or adjust them into negative power of z, I need to divide the whole equation by z square. So when I divide the whole equation by z square, I will get 7 z square cancelled minus 5.25, one z will get cancelled, the second z will remain, which I will write as z inverse, plus 1.375, as there is no z square, it becomes z raised to minus 2, divided by, here also will be 1 minus 0.75 z inverse plus 0.125 z raised to minus 2. Now h of z is done. Now we can proceed for the structure. We know that this is a numerator polynomial, this is my a0, this is my a1, this is my a2, this is my b0. Now as we see that this is my a0, a1, a2, b0, b1, b2, let us now draw the structure. So we know that the previous structure, so I will just keep my page so that you can see the things. Okay, so or let us rewrite this thing. So let me rewrite the complete transfer function again, so that it will be in front of your eyes when you draw the structure. Okay, so this is my a0, a1, a2, b0, b1, b2. Okay, now what I will do is I will first make the strings of z inverses. As we see that in the numerator as well as in the denominator, the highest degree is minus 2. So I will require 2 delay blocks or 2 z inverse blocks in left hand string also and in the right hand string also. So let us first draw 2 z inverse string. This is string 1, so I will draw 1 z inverse and the second z inverse. Here also I will draw 2 z inverse string. One is this z inverse and the second one is the z inverse. Okay, now from the first z inverse I will take out and I will connect a adder block to it, and then from the last block I will just connect here, because adder requires 2 inputs. Okay, similar way here also there will be one adder, and also here there will be one of the adder, and this will get connected over here. So get connected over here. Okay, now this will come over here. Now from this side I will get my x of n signal, from this side I will pull out my y of n signal, right. So all b0s will go in the reverse direction, all b and b terms will go in the reverse direction, a terms will come in the forward direction. So this will be my a0, which is 7. Then I have minus 5.25, so it will be write with different color, it will be minus 5.25, because for the numerator polynomial I am not going to change the sign, so signs will be retained. Here it is plus 1.375, so I will write plus 1.375. Then over here I will have b0 going ahead, then b1 is minus 0.75. I need to flip the signs. So here it will be plus 0.75, that is my B1. I have to flip the sign, negative becomes positive, and here positive will become negative, so it will be minus 0.125, and that will come as the feedback path. So this is what the overall structure. So this becomes my H1 of Z, this becomes my H2 of Z, product of which will give me H of Z. So this is what a direct form 1 structure is all about. So if the question is not given in proper form, or you need to by default get H of Z. If difference equation given, then you apply Z transform and get H of Z. If not given in proper order, you have to first rearrange in a proper order and get H of Z, and from H of Z, numerator polynomial coefficients will travel forward direction retaining the sign, whereas the denominator polynomial coefficients will be going in the backward direction with sign change, flipping the sign. That is what all about direct form 1 structure. Thank you.